You're on a construction site, and you see a horizontal member over a window. Another crew is installing a large, deep member spanning between two columns. Someone calls both of them a beam. But are they the same? Absolutely not. Understanding the difference between a beam and a lintel isn't just about semantics, it's about understanding the fundamental load path in a building. And getting it wrong can lead to serious structural issues. In this video, we're cutting through the confusion with a simple, powerful analogy. We'll explain the one critical question you need to ask to tell them apart instantly, and we'll break down their unique jobs, load types, and design requirements. By the end of this, you'll never mistake a lintel for a beam again. Let's start with the core principle. The difference is not about size or material. You can have a small beam and a large, deep lintel. The difference is all about what they are carrying and from where. A lintel is a localized support member. Its primary and singular job is to carry the load from the wall or masonry directly above an opening. Like a door, window, or passage, and transfer it to the supports on either side. Think of a lintel as a local hero. It has a very specific, focused job to bridge a gap in a wall so that the wall above doesn't collapse into the opening. It deals with a triangular load of masonry right above it. A beam, on the other hand, is a primary structural member. It carries loads from the floor slab, other walls, or even other beams, and transfers them to columns, walls, or girders. A beam is a main character in the structural story of the building. It supports the entire floor system. So, the one question to ask is this member supporting a wall over an opening, or is it supporting the main floor structure? The answer will instantly tell you if it's a lintel or a beam. Now, let's dive deeper into the load path, because this is where the engineering diverges. A lintel carries a triangular or trapezoidal load. The weight of the masonry courses above the opening arches inward and transfers its load to the lintel. The highest load is directly in the middle of the lintel. Its supports are typically the wall on either side of the opening, and the span is almost always short. A beam, however, carries a much more complex load pattern. It can carry uniformly distributed load from a slab, point loads from secondary beams, or a combination of both. Its supports are major structural elements like columns or load-bearing walls. And its spans can be very long. This difference in loading directly impacts their design. A lintel is often a standardized, precast concrete element or a simple steel angle. Its design is relatively straightforward. A beam requires detailed structural analysis and design. An engineer must calculate the bending moments, shear forces, and deflections. It will have specific reinforcement detailing in concrete or a specific section modulus if it's steel. A pro tip for site engineers is to always check the structural drawings. A beam will be meticulously detailed on the structural sheets, while a lintel might only be noted on a wall section or in the architectural specs. Because of their different roles, the consequences of failure are on completely different scales. If a lintel fails, the result is localized. The wall above the specific opening it was supporting will crack and potentially collapse into that opening. It's a serious problem. But it's generally contained. If a primary beam fails, it's a catastrophic event. It can lead to the progressive collapse of the entire floor system. With supporting, as the load path is completely severed. This is why the inspection and sign-off for a beam or steel beam connection is a major milestone, often requiring the presence of the structural engineer, while a lintel installation is part of the standard masonry inspection process. To summarize the key takeaways in one simple analogy, a lintel is like a sturdy shelf bracket holding up a stack of books over a doorway. Its job is very specific and local. A beam is like the main shelf itself, holding up all the books, the vase, and the potted plant for the entire room. One is a specialized component, the other is a primary structural system. Now I want to hear from you. In the comments below, what's the most creative or complex beam or lintel application you've ever seen on a project? Was it a massive, decorative stone lintel or a transfer beam holding up multiple stories? Your examples help make these concepts real. If this 2-minute guide has cleared up a common confusion, please give this video a like and subscribe.